Bismillahirrahmanirrahim. Dear viewers, today we will see how to apply wall load or line load in Cype 2020 and how to model Stair, then analysis and design. Now we are in Plinth beam level, so from Plinth beam to ground floor roof, the story level we can check from column definition, floor. Here we can see 3.5 meter all up to roof, then stair top 2.8 meter. So now in Plinth beam we will take the story height. Here wall width we have to consider here according to the architectural plan. So if it is 20 centimeter, it's okay. Floor height 3.5 meter. Top beam depth, that means this is Plinth beam. On top of this beam, if the floor beam is, this is 25 by 50, so depth is 50 centimeter. It will be reduced from the floor height to get the actual wall height. So now here top beam depth 50 centimeter. Unit weight of this brick wall, usually we use 1450 kg per meter cube of hollow block, so that is giving us 14.225 kilonewton per meter cube. So line load from wall, it is coming 8.53 kilonewton per meter. So here we will go line loads on beams 8.53 kilonewton per meter. Here wall load will be included in dead load. So click on add. We will provide same wall load here. For different top beam depth, you can provide different loading as per the calculation in Excel. Now we will go to upper floor. Here I will provide same loading because floor height is same 3.5 meter, although the top beam depth is somewhere 60, somewhere 70. So if I reduce this depth, then load will become less. If I provide here 60, then it will come 8.25. So I am going with same loading for saving the tutorial time. Click on add. I can click like this to provide loading on all the beams. I will remove load from here. Loads, delete, click on this, it will be deleted. Okay, so these loadings applied all the three floors because this floor is in typical floor group. Now we can go to upper floor to roof. Here we will apply load on beam. In this case, here we will apply parapet wall load. For example, here parapet wall height 1.5 meter, top beam depth 0, so it will give 4.27 kilonewton per meter. 4.27. This side, this side. Parapet wall load, and here we will apply stair head load. Stair top height 2.8 meter, top beam depth for example 50 centimeter, so 6.54. 6.54. Add. Okay, So our line load application finished. Now we can model our stair. Save this project. To model our stair, we have to break our typical floor group, because when we will go to Plinth beam level, from here we will start our stair, and the next floor here, the floor level 1, that is included in typical floor. So top of the stair will not get the single floor. I am showing you how it will make problem. Here we have 10 steps, and this is the dimension for landing. Go to stair, new staircase, stair 1. Here stair width 1.05 meter, 105 centimeter, that means 1.05 meter, 05. Thread is 30 centimeter, 0.3. Riser, here we can calculate floor height 3.5 meter, total number of steps 20. So riser is coming 3.5 divided by 20, 0.175 meter. So this is okay. Rotation, if it is left to right, then left. If it is right to left, according to the architectural plan. So this is up, that means from here stair will start. So we will click on right. Okay, load step loads, that will be poured with concrete slab, not using bricks. So this one will be selected, and here we can see the waste slab matching with the bottom. We can choose it matching with the top level of landing or floor level. Here click on this. Railing load we can apply here, for example 3 kN per meter. Floor finish can provide 2 kN per meter square, and live load we can provide 3 kN per meter square. Now go to span, click on add. Here we can create S20. Depth of flat slab, that means waste slab thickness 20 centimeter, that means 0.2 meter. Start level difference, we have no level difference in starting. And this is predefined shape, this is the shape. Other shapes are also available. Step 10, and this gap is 10 centimeter, 0.1 meter. Steps built in on intermediate landing. Here if there is any extra step we can provide here. Intermediate landing, this is supported. Location front, so as we have selected right, that means from left to right, so we will make it right to left. We will select left. As usually we use landing beam to support our landing, but here that option is not available, so we can use with connector. Width we can provide 0.25 meter. Here this one we need to change. Sorry, here 20 centimeter we can provide same, 0.2 meter. Now here 1.05 meter we will check. 1.1 meter. Here for landing width, if it is different, we can click on this 1.1 meter. This is 1.1 meter. So click on accept. If we click on this and then here orthogonal position, now this stair we can move from here to snap this position. Click on this, then snap end point, except will be at the end. Okay, now here we can see in 3D view the stair not generated. Here not generated because we need to break our group. Here another stair, if we draw stair 2, copy from this one, same properties, except here you can see the initial group typical floor T1 T3 has more than one floor. So in this group there is 3 floor, that's why the stair cannot find out the single floor to finish its flight, so it will give the error. So now we can delete staircase, this one also. Now we will go to column definition. We can go to floor or group, divide group, here this one, accept, divide group, this one, accept. Now we can see floor all are different. Now we can model our stair easily. Go to beam definition. Now go to stair 1. Only we will change the rotation. It will go left from this side to this side, right to left. So choose left, span this S20, click on accept, select anywhere, then go to orthogonal, click on this. Now move end point like this. We can see in 3D view the stair generated. Okay, we can go to next floor, stair 2, copy from this stair properties, accept, then move same way like this. So our stair modeling also finished. Go to foundation level, here remove the AutoCAD view. Now foundation elements, selection type, here square footing or centered rectangular footing, click on accept. Here we can delete this one, then new, multiple column elements, rectangular except this and this. Right click. Like this we can provide combined footing. Close this one. Now we can see in 3D view these footings are showing. This is not designed yet. We need to analyze the project including foundation. Here some overlapping foundations found, must be deleted. Go to foundation, delete this one, and this one, and this, because for this footing, this combined footing is going to longer direction. New type centered rectangular except this one, right click, left click, like this, right click, left click, this and this, right click, like this. Now we can go for foundation design, quick design with minimum dimension. This foundation is overlapping. Here we can do another thing. We can delete this one, then new single type. For this two column we can go for a square footing for different example. Okay, now design. Okay, now our foundation design done. Here we can provide the allowable bearing capacity of soil for foundation. Go to project general data. Here foundation 0.2 MPa. From here also you can see the bearing capacity. Gravel 294 MPa, dense sand 245, medium dense sand 196, loose silt soft clay 0.098. So this is for accidental condition. This is for normal bearing capacity. So we can go with 0.2 MPa and for accidental 0.3. Accept. Now we can go for foundation design. We can see foundation in 3D view. Now we can go for Plinth beam level. Here remove the AutoCAD template from view. Now we can see the result. This is Plinth beam, this floor level, this slab also designed with reinforcement. We can check our column first. Go to column, edit, check any column. Here we can see this column we have selected, this one, and other columns are also in the list. We can first edit our C1. So all the columns we can see failed due to seismic criteria. So here we can edit this column. For example, if I provide this column width 30 cm, 30 by 50, then it is passing. Here you can see, here we can edit in top level. Automatically it will edit below levels also. Enter, see here 30 30 and here 50. Now this passed 30 by 50. Here we can see equilibrium diagram of the section of the selected combination. Here is the governed combination. In this way, C2 also we can check 30, press enter. This two floor it is failing, so here we can change the Y distance also. So this passed. In this way we can edit the columns. So we can see 3D view for column with reinforcement, forces. Here load cases, different load case like this. We can see detailing for this column. Edit in columns schedule also from here. Yes, accordingly the column changed. Here we can edit our beams also. We can check beam, edit like this. Here it is showing bottom reinforcement anchorage problem. Later on we will see how to solve this issue in another tutorial. Now here see the section we can provide here like this. Here, here, here. In this way we can provide the section view in our output drawing. Close this one. Yes. Now we can go for the slab contour maps. Here we can see this with contour lines, displacement along z direction for dead load, live load combination. We can go for deformed shape, scale for displacement. Here we can see the animation. Hundred with the slab. This is the displacement animation. Close this one. Exit. You can go for generating report, job data report. Here we can choose the options as per our requirement, then we can accept to get the report. Then we can convert it to PDF file. Okay, now we can go for detailing option, drawing, add. We will add floor plan, accept, then add detailing of columns, accept, add frame drawing, accept, column schedule, accept, then click on accept. So this is the drawing sheet. View detail of all the drawing. Print all the drawings in one file. Choose the destination folder. Desktop, okay, accept. So this is done. This is the foundation layout plan. This is plain beam, this floor beam. So all the drawings we can generate from CypeCad in this way. Here we can do analysis and design of stair also. Go to stair, view details, select the stair. So this is the stair details as per the design. This is very fast. Forces and displacement we can see. We can see view with structure, contour maps. We can increase the scale factor of displacement view. Here is the animation for displacement. Close this one. We have defined lateral loadings in the beginning of the model. We can do it later also. From here, general data. Here we can click on with wind loading and with seismic loading. Before we have defined wind loading tributary width manually. After modeling we can do it, we can get it automatically by floor using this. So in this way we can do analysis, design and detailing of RCC structure in CypeCad 2020.
Press the bell icon on the YouTube app and never miss another update.